Dark matter is a hypothetical form of matter that is thought to exist in the universe but has not been directly observed. It is called dark because it does not emit, absorb, or reflect any electromagnetic radiation, making it invisible to our telescopes. It makes up approximately 27% of the universe's mass energy density. Its existence was first proposed by Swiss astrophysicist Fritz Zwicky in the 1930s based on observations of galaxy clusters moving at velocities much higher than expected. This phenomenon suggested that there was a large amount of unseen mass holding these clusters together. The properties of dark matter are still unknown, but scientists believe it is composed of weakly interacting massive particles WIMPs. WIMPs are thought to interact via the weak nuclear force and gravity, but not electromagnetically, rendering them invisible to our telescopes. Dark matter is lightly cold, meaning it moves slowly compared to light. Its particles may interact with normal matter through elastic scattering, which could provide clues to its nature. Scientists have been studying the distribution of galaxy clusters and large scale structures to understand dark matter's role. The role of dark matter in galaxy formation is crucial. It provides the gravitational scaffolding for galaxy formation, allowing normal matter to come together and form stars and galaxies. Without dark matter, galaxies would be diffused and disorganized. Dark matter influences galaxy morphology and evolution. The large scale structure of the universe is also influenced by dark matter. Galaxies and galaxy clusters form along filaments, with dark matter providing the gravitational framework. This framework helps explain the web like structure of the universe. Scientists employ various methods to detect dark matter directly or indirectly. Direct detection experiments use highly sensitive detectors to measure the scattering rate and properties of dark matter. Indirect methods involve observing products of dark matter annihilation or decay. Particle colliders like the LHC search for evidence of dark matter production. Colliders create high energy collisions that may produce dark matter particles. Gravitational lensing reveals dark matter's presence, bending light around massive objects. Alternative theories propose modifications to gravity rather than invoking dark matter. New discoveries will shed light on dark matter's nature. Theoretical frameworks provide context. Experimental searches push boundaries.